Today I'm going to talk about LeetCode question number 139, daily temperatures. Given an array of integer temperatures represented daily temperatures, return an array answer such that answer at position I is the number of days you have to wait after the ith day to get a warmer temperature. There's no future day which this is possible. The answer at position I is equal to 0 instead. So basically what it's asking, given the temperature, count how many days it will take to get a warmer temperature. Okay, so we have 73 here. We have to wait 1 day to get a warmer temperature, and that's 74. Okay, and if we have 75 here, we have to wait 1, 2, 3, 4 days till we get a warmer temperature of 76. Okay, and that's reflected here. 75 is at position 0, 1, 2, and that position 0, 1, 2 of the output array, we have 4 because we have to wait 4 days to get a warmer temperature. Okay. A brute force would be to look at each element one by one and then scan the rest of the array to find a warmer temperature than it. So for example, we have 73, 74, 75, and so on. So, for example, if we have this element here, we can scan through the rest of the array here to check if there's a temperature warmer than it, the first occurrence of the temperature warmer than it, and we have it here. Okay, so that's great. We found 1, a difference between the positions, position 1, position 0, so 1 minus 0 is equal to 1, and we have that here. Okay. But this would be O of n squared time, just because for each element we're scanning through the rest of the array, and that is a nested loop, and that is O of n squared time, where n is the length of the array. But we can do better. So I'm going to use, so basically when we have a temperature here, okay, we want to remember this temperature just in case we find something larger than it, so we can store it in a stack. Example 73. Okay, and then if we go to the next temperature, 74, we check this stack to see if there are any temperatures smaller than it. Okay, and if there are, then we found the result to put in our output array. So for 74, we look at this stack. Is there a temperature in the stack less than 74? We do have one, so we pop this. Okay, any more? Nope. So we add 74 to the stack, because for now we want to search for a temperature larger than 74. And as we pop this in our result array, at position 0, we have 1. Okay. Similar for 75. We're looking at 75 now, and we look through the stack. Are there any temperatures less than 75? If we do find them, then we have to pop them and return the difference between the positions in the result array. So we found 1, we pop it, now we put this in the result array of 1, and then pen 75. Okay. What about the rest of the elements here? I'll complete this list. 72, 76, 73. This list continues down here. Okay, and 75. Now we look at 75. Now let's look at 71 here. Are there any elements in the stack less than 71? No. So what we do is just add 71 here, and we'll just remember it. Okay. Yeah, this guy needs a temperature larger than it. Okay. About 69. Nope. And what about 72? We do have 69 here, which is smaller than 72. So at the position 69, so 0, 1, 2. This is missing, and at position 69, we have 1. Okay. So then we pop 69, and we also found 71. 71 is smaller than 72, so we pop that too. And at the same position 71 is at in our result array, we put in 2, because 72 is 2 away from 71. Okay, about 75, is that smaller? Nope, we still have to find the greater temperature for 75. So now we just pop push 72 here. Okay, and so on and so forth. And that's how we'll go about it. So this is an example of a monotonic stack. Okay, and a monotonic stack is a stack whose elements are monotonically increasing or decreasing. Okay, so basically in here we are storing monotonically decreasing values. Okay, and that's how we'll go about this daily temperatures question. So now coding this up here, what I'm going to do is initialize my result array of length temperatures, and initially it's going to be all zeros. And this will help in the case where we do not find a temperature larger than the temperature at that position. For example, the very last one. 0 times 1 temperatures. Okay, and then our stack, and this will be a monotonically decreasing stack. Okay, so for each position value in temperatures. Okay, so in the stack, what I'm going to do is store a tuple, and in this tuple we will have the temperature and the position it was in this temperatures array. So for example, if we had 73 here, it'll be at position 0. Okay, so like 73, 0, and if we have 74, it'll be at position, it'll be 74, position 1. And I'm going to store both the value and the position, so I could subtract the position from the larger temperature from this temperature here. Okay, so that's what I'm going to do. Okay, first of all, if stack is empty, what I'm going to do is just basically push the temperature value and the positions located in the temperatures array into the stack. Okay, or else, and then after that just continue, start from the loop again. Okay, or else, while the length of the stack is not 0, so while stack is not empty, and stack, and at the very last element of the stack, and this is going to be this is basically our peak function here, so we're going to peak what's at the top of the stack. While when stack minus 1, 0, 0 represents our temperature in this tuple. In this tuple, our temperature is at the 0th position. It's less than the current temperature value. What we're going to do is pop from the stack. So pop temperature equals stack.pop. Okay. And then what I'm going to do is now append to result at position that I stored the popped temperature at. Okay, I'll just make a note here. Okay, so at the position that this original temperature was in array temperatures, I'm going to store position of the higher temperature minus position of the smaller temperature. Okay, and then after all that, I'm just gonna add this temperature into the stack in hopes of finding a larger temperature than it. Okay, and then after all that, I'm just gonna return result. Okay, now let's try compiling. And this will be all of O of n time. It's linear time. Okay, I'll try using the other example cases. Sweet, and I'll submit. Okay, and thanks for watching.